For this question, we're told to assume ideal diodes, and we're asked for the circuit shown, which of these is correct. So we're going to go through these step by step, but first we're going to go over some basic information about our circuit right here. Since we only have one diode and one voltage right here, it's going to act as a clamp, and it prevents the output voltage from going below our negative V1. And we could actually draw a little diagram of this right here. So if we have our graph like this, and we know our input voltage is on the X, and our output voltage is on the Y, which is V out, we have some limits here. Now notice the direction of our diode. I like to think of it as, well, the diode is pointing upwards, and so the backside is right here. And when it's like this, if we look at the notes linked below like button, we're going to have something that looks like this, and we can use this as a base. Well, that means our diode is going to look like this. So the bottom is right here, and then it's just going to go up forever like this in a 1-to-1 gain, because gain is voltage output over voltage input. Now, the difference here is that we have a battery. So this battery is going to determine where we start, how low we are, because of the direction of our diode. If it was like this, the diode was reversed, it would be up here. So this is another example like this. So for this, we are just going to say that, well, this is our V1 right here, right? And it's negative. So we're going to have a negative V1, and our diode is going to go, our voltage, the gain is going to go like this, and then it's going to go up just like that, or something like that, a little bit straighter than that. And so that is how we would draw this out. So it's going to prevent the output voltage from going below the negative V1 right here. And note the diode direction. The minimum output voltage is negative V1. So what we have here, that's the minimum it can go. If the output voltage is lower than V1, we would forward bias the diode, and then it's just the battery across our output. So if it's lower than the diode, it's just going to hit right here. When the output voltage is above our negative V1, so when we go greater than what we have here, the diode acts as an open circuit. So that means that this and this is going to be basically disconnected from our circuit, and the current is just going to flow through like this. And we don't need to worry about this. Therefore, the whole diode branch is going to be not looked at. And it looks like the nodes got cut off, but this is whenever the voltage output is going to be greater than our V1 right here. So whenever the V out is greater than our negative V1, that's important to put. So now that we know that, we can look at what we have here. So we have to come back to A, but let's start looking at B. So with B, the gain is equal to 0 when V is greater than negative V1. Well, let's look at this. When our gain is 0, we know that's when V out over V1 is equal to 0. So when this V1 is really big, right? Well, or if this V out is super small, basically kind of saying the same thing. But here it's saying that our voltage input is greater than our negative V1. And we know that our V voltage input is right here. And if it's greater than our negative V1, remember, because this is like this and this is right here on the x-axis, if it's greater than it, well, we're going to have something that looks like this, where the gain is 1. So either this would have to be 1 if it's changed, or this is going to have to change to where it says the gain is equal to 0 when our voltage is going to be less than our negative V1. So we can either keep this and this, or we can just replace this with a 1. Next, we have the minimum output voltage is plus V1. So for this one, if we look at this, our minimum output voltage is, yes, the V1 right here. However, note that it is a negative V1 because of where we are at right here. So this is going to be incorrect because this should be a negative. So it's not B or C, and so obviously it cannot be A, which is all of these either. Now looking at D, we're going to have the maximum output voltage is not limited. So what is our maximum output voltage? The maximum output voltage, we can see, goes on forever like this. So yes, it's not limited. And so this would be the correct answer. But let's keep on going here. Now that we know D is correct, we can look at E. For E, it says the gain is equal to, remember the gain is written like this, or we can use the resistors. resistors are our RL, because if we use voltage division, RL over our R plus our RL, and that is the correct voltage division. Now, this next part, when V is less than or negative V1, we know that if we look at our graph, the slope here is going to be 1 to 1, right? And that is what our gain is with the resistors. Now, we're going to get this when our gain is a V, because remember, V is the voltage input, has to be greater than our negative V1. So this is incorrect as well. This has to be greater than. Because remember, resistors they're fixed values, right? And our voltages, they can change, they're varied. And so when our voltage V, this V right here, when it is less than our negative V1, well, if we bring it down here, we're just going to see that the gain is equal to 0, not our RL over our R plus RL. And so that is where our incorrectness comes in. And so with that all done, we can see that E is also not correct. We've gone over the material and this problem. It's a lot of information about diodes in one problem, so if you have any questions, you can leave them in the comments below the like button. And that is it for this problem and anything like it. There's going to be another problem just like this in the playlist linked below the like button that deals with this kind of same thing, but with our options a little bit different. So we just review the material again, and we are going over what makes these specific things true or not true.